वेरी गुड आफ्टरनून। वेलकम टू अनअकैडमी। तो दोस्तों कैसे हो आप लोग? प्लीज कंफर्म द ऑडियो एंड वीडियो। प्लीज कंफर्म द ऑडियो एंड वीडियो। ओके, just give a minute. Okay, so let's start the session. So sorry for the delay, my dear friends. So I'm your friend Ashwarya, expert in GATE ESE and SSC JEE. I have done my MTech from IIT Delhi, Geotechnical Engineering, batch 1113, and BTech is from Jamia Millia Islamia Delhi, batch 711. दोस्तों 4 times I have qualified GATE with my best rank 226, and I do have 6+ years of teaching experience and 2 years of industrial experience. Okay. So these are the subjects which I basically take on Unacademy official YouTube channel as well as on Unacademy Plus. Theory of Structure, RCC, Geotechnical Engineering, तो ये सारे सब्जेक्ट लेता हूँ मैं अनअकैडमी पर। और ये है वो रेफरेंस कोड माय डियर फ्रेंड्स जो आपको लगाना है बिफोर बाइंग एनी अनअकैडमी प्लस सब्सक्रिप्शन, AISH10 Okay, so by using this code, directly you will be getting benefit of 10% on your Unacademy Plus subscription. Okay, and these all are the benefits of Unacademy Plus subscription. It is having daily live classes, crash courses, rank improvement batches are here. It is running on both the languages, English as well as Hindi. So dedicated doubt clearing sessions are there, weekly tests are there, and on the top of it, students or learners may be having a very good interface to interact with the educator, or you can say with the teacher. Is it clear? A very good evening Shashi, very good evening. Chaliye. So these are our Unacademy schedule. So Chetan sir is taking hydrology till 10th of September. I will take structure till 20th. Minimum it will be 20th. It may extend by 1 or 2 days. And fluid mechanics is being taken by Mrigang Saurabh sir. And environmental is taken by Chetan sir. Geotechnical engineering, this is running batch. So geotechnical engineering by Abhishek Bhartiya sir is also here. Steel structure by Babulal sir is also here. And Kshitiz sir is taking RCC in the night batch. And engineering mechanics will substitute my structure analysis. Once I'll complete structure, then Chetan sir will resume mechanics. Okay, is it clear to all my dear friends? So guys, today is the 4th lecture on laterally loaded pile. So today and next session will be on Monday. So these are the announcement. Geotechnical engineering. My geotechnical engineering means the topic which I am taking here. So its next class will be on 7th of September. So it will be off tomorrow, and Sunday it is already off. So this batch will run 5 days in a week, and after that, what? Just a minute. The sound is creating disturb. Mm, okay. Yes. So next class of Geotechnical Engineering is on 7th of September. Okay, my portion of Geotechnical Engineering. Okay. 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 So good afternoon, Rupinder and Shashi. No class tomorrow, only of Geotechnical Engineering. Structures will be there. Tomorrow or day after tomorrow, a session for marathon may happen. So that is the reason why we are not keeping the regular lecture on the evening slot. Okay. So yeah, this is the important announcement. And next class of structure, next class of structures is tomorrow only, for 5th of September. 5th of September, timing 10 a.m. to 11:30 a.m. Okay. So far we have discussed the causes of laterally loaded pile. What are the various head conditions we have seen? What are the various procedure to analyze laterally loaded pile? And we have started yesterday Rees and Matlock method. Okay. So today I am continuing the analysis part. Okay. So what I told you yesterday, that I am going to start from this equation. I hope you know this equation. So I'm not going to repeat today because already slot is too less. So with this equation, my dear friend, I'm going to start the analysis for both of the cases. What are the cases? दो cases के लिए हमें discussion करना है. पहला, free head condition. कल काफी डिटेल्ड वे में स्लोली मैंने करवाया था आपको. और दूसरा है मेरे पास फिक्स्ड हेड कंडीशन. So my target is to cover these two in today's session. Okay. Okay. Yes. So it is like that. Okay. So today I am going to start from this differential equation and the solution to this differential equation, which is obtained from the strength of material concept. Okay. So the solution to this differential equation is going to tell you all the things about pile, like deflection, slope, bending, shear, reaction. Okay, so all these things you can obtain by using this. It is KH. So both the notations are used, KH as well as KS. So I will use KH from now onwards. Okay. Yes, Shashi, tomorrow you can enjoy my structure lesson. Don't worry. Okay. So रुपिंदर जी बढ़िया है हम, आप बताइए. Okay. Is it clear to all? Okay. So now my dear friend, first of all give the headings. Free head condition. So today I am going to discuss both the condition, free head condition and second is fixed head condition. Free head condition and fixed head condition. Is it okay? Okay. चलिए रुपिंदर, आप फॉलो कर रहे हो इन लेक्चर्स को? मुझे लगता है अभी नहीं आएंगे समझ में आपको, है ना. ये वो वाले टॉपिक है जियो ट्रैक के जो गेट में नए ऐड हुए हैं. क्लियर है? चलो, तो ये आज के हमारे दो मुद्दे हैं, फ्री हेड एंड फिक्स्ड हेड. वन सेशन आई विल टेक मोर on laterally loaded pile because so that I can discuss some numericals, and today I am going to tell the theory behind this analysis, that what are the various differential equation involved and how they are obtained. Okay, and how to use this theory. This I'll try to put some light on it, and after that we can discuss some problems on Monday. Is it okay? Okay. So give the heading free head pile. Free head pile. So whatever today I am going to teach, it is after this equation. After this equation, you can call it this equation as governing equation. Governing equation. And how I obtain this equation, you can refer to my yesterday's lecture for that. So my dear friends, in free head pile, deflected shape gives slope of top of pile at surface by an angle any angle by an angle at say theta. So what I want to say here, suppose if this is your ground level and these are the piles, and if I am going to apply any load here, lateral load here, so due to this load what can happen, you can have slope here. जैसा कि आप यहाँ पे देख सकते हो, डिफ्लेक्शन तो यहाँ पे है ही है, इसके साथ साथ you will also be having some slope, let's say theta. Okay, so this is a case which we want to analyze. Okay, is it clear? Okay, so how we are going to analyze it, we have to see that. So we will use the principle of superposition. Suppose this is my pile and which may be subjected to, this pile may be subjected to axial load, sorry, lateral load, and moment. Let me call this moment as mg and let me call this lateral load as qg. Okay, and this is ground level, so I cannot keep it fixed. Let's say it is ground level. So my dear friends, what I'm going to do here, I will break this loading into two components. First one, I'm going to tackle only lateral load, and in second case, I'm going to show only this movement. This movement may be originated from the axial loading due to the eccentricity of the axial loading. So what I'm going to do here, I'm simply going to divide this configuration into two parts. Okay, so let me show them one by one. So first portion is this one. First portion is this one. In which only lateral loads are considered. Okay, and second is plus second component is this one, where only moments are considered, where only moments are considered. Is it clear, my dear friends? So second portion is going to have only moment. Okay, second portion is going to have only moment, and let's say it is mg. Okay, so now what is principle of superposition is saying? What is principle of superposition is saying? The principle of superposition says whether I'm going to take both of these forces together or I'm considering them independently, then I'm adding them, both are going to give the same result in an elastic material. And it is our assumption that pile is long and long pile will be considered as elastic pipe. And these deformations are considered to be small in comparison to dimension of the pipe. Okay, so now what I want to tell you, if you want to know the deflection here, let's say, try to understand this thing. If you want to know, let's say, suppose you need this deflection, let me call it as y. So this is the combination of this one and this one. So if this is known as ya and if this is known as yb, then the total y is equal to ya plus yb. Ya plus yb. This is superposition. That this independent deflection at a distance x from top, if you are going to add them up, you are going to get the final deflection. So here you are simply breaking your structure, breaking your load into multiple load, है ना? जैसे स्ट्रक्चर एनालिसिस में करते हो कि बीम के ऊपर एक साथ लोड लगाओ या एक एक करके लगाओ. जब आप एक साथ लोड लगाते हो तो रिजल्टेंट इफेक्ट मिलता है, जब एक एक करके लगाते हो तो इंडिविजुअल इफेक्ट मिलता है. So जब आप इंडिविजुअल इफेक्ट को जोड़ते हो, then you are going to get the final deflection. Is it clear? Okay. So this y is equal to ya plus yb, not only at the top, but I would say at any depth x, at any depth x, at any depth x, it is equal to ya plus yb. Okay. So ya, yb, let's say the corresponding deflection at any depth x. Is it clear to all my dear friends? Okay. So whatever I have written, it is for deflection. And whenever I am saying deflection in a pile, it always means the transverse deflection. So this is the deflection. Whenever you are seeing a deflection in a beam, so beam deflection, it is vertical direction. And deflection due to lateral load in pile is the horizontal deflection. Okay. There as well, deflections were perpendicular to the beam axis. Here as well, the deflection is perpendicular to the pile axis. Okay. And if you are considering this vertical member as beam member, then you can say here as well the deflection are perpendicular to the beam axis. Okay, so now let's see, my dear friend. Whatever I have written here, it is only for deflection. It is not only valid for deflection, it is valid for slope, for movement, for shear force, for bending moment. For each and everything, you can say that these parameters are valid. Like slope at x, like slope at x distance is equal to slope at a plus slope at b. What is a? A is the component of slope due to A is the component of slope due to lateral load. B is the component of slope due to the movement. And for this movement, your axial load due to some eccentricity may be responsible. Like it was here. YA is the deflection at the first pile due to lateral load, and YB at the same location deflection at the another pile, okay, due to mg, due to movement. Okay, so if in reality movement is absent, then this and this will be same. If in reality qg is absent, then first and third will be same. Is it clear? Good afternoon, KDG. Now see next. So yx is ya plus yb. So now I can write here yes. See, see Rupinder, see, just listen to me here. Whatever I am right, like y is equal to ya plus yb. I hope no doubt is here. Y is equal to ya plus yb. So no doubt is here, I guess. Okay. So similarly, slope is also equal to sa plus sb. What I want to say, just listen to me, Rupinder. Suppose this is a beam. Now listen to me very, very carefully. Suppose this is a beam. And you are applying here a point load at the center, let's say P. So the deflection due to this at center is PL cube up, WL cube upon or PL cube upon 48 EI, and slope at here is equal to how much it is? It is P L square upon how much? 16 EI I guess, है ना, जो भी हो देख लो. अब जब क्या किया मैंने नेक्स्ट टाइम I am applying some other load here, let's say UDL. So due to this, what is the deflected pattern? Deflected pattern is like this, and let's say this deflection is WL4 upon 384 EI, and let's say this slope is WLQ upon 24 EI. Okay, ऐसा मान लेते हैं, है ना? Okay, so now when both of them forces are going to act together, when both of them forces are going to act together, what are those forces? This UDL as well as at this P. So now Rupinder, you only tell me what would be the end slope. What would be the end slope now? Theta. Theta would be what? Please tell me this. So will it not be equal to theta due to P as well as theta due to UDL W? So you have to write theta here will be equal to PL square upon 16 EI plus WL cube upon 24 EI. Okay. So similarly here as well, I have written that slope at any distance x from the top is equal to slope here as well as plus slope here. So SA is the component of slope due to the lateral load action, whereas SB is the component of slope due to the mg action. Okay, so this is what I want to tell. Not only slope and deflection, but other than slope and deflection, your movement, your shear, your reactions, each and everything will get superimposed. Okay, so what I want to say, the crux point here is, so deflection at any distance x, vertical distance x, would be equal to a plus b. So A and B are not representing only the top deflection. It is general one. Okay. So I'm intentionally removing this X sign. Okay. So don't think only top values are YA and YB. YA is variable only. YB is variable only. So YB is variable for this pile. YA is variable for this pile. And Y is overall variable. And here by X I am representing distance X. Okay, from the ground level. So if Yx is equal to Ya plus Yb, if Yx is equal to Ya plus Yb, so in that case, my dear friend, tell me, how, what can I write for slope? So it is also equal to Sa plus Sb. Similarly, if I want to ask what about moment, so Mx is also equal to Ma plus Mb. Similarly, if I want to know about the shear force, so shear force at any distance x is also equal to Va plus Vb. So like that. So basically A is taking care of lateral load and B is taking care of moment, because that moment is also, yes, that moment is also causing slope and deflection in the lateral direction. Is it clear to all, my dear? Please let me know if you are having any doubt till here. Please let me know if you are having any doubt till here, my dear friend. Okay, is it clear to all? Tell me, is it clear to all? Okay. Now see here. I would like to start with the deflection. So Yx, I have learned that it is equal to Ya plus Yb. Okay. Now, what we have seen here, that your Y, okay, is a function of x. What is x? X is distance from the ground level, okay, or from the top of the pile. Okay, length of the pile, what is the total length of the pile? On that value as well Y is depending. If length of the pile is more, so deflections may be large, and if length of the pile is less, it may act as a rigid pile and deflections may be small. Okay, T I am going to explain later. At the end I am going to explain T, but yes, T you can call it as stiffness factor. Okay, stiffness factor. It depends upon soil. It depends upon your Young's modulus of pile. It depends upon the geometric property. So on these three parameters, your stiffness factor is dependent. Means it is taking care here about the soil as well as about the material as well as the geometry of the material. Okay. So T here is known as the stiffness factor, and its exact formulation I am going to explain you at the end, because that is a process of derivation. I am going to tell what is T, experiment formula wise. Okay, it depends upon KH. I hope you all know what is KH. Okay, it is depending upon EI. It is depending upon QG. QG is lateral load, and it is depending upon MG. So total you can say your deflection is going to depend upon 1, 2, 3, 4, 5, 6, 7. 7 parameters. X, total length, stiffness factor, KH, EI, Young's modulus and moment of inertia, QG and MG. If you are considering EI as single quantity, flexure rigidity, then you can make it one. Or if you want to further bifurcate them into two parts, then you can say this Y is a function of 8 things. X, L, T, K, H, E, then I, then QG, then MG. Is it clear to all my dear friend? Tell me. Any doubt so far? Any doubt to anyone? Okay. So now my dear friend, I hope all of you know the Buckingham Pi theorem in fluid mechanics. Okay, in dimensional analysis, we study dimension and analysis, we study Rayleigh method, we study Buckingham Pi method, and from there we are trying to obtain the dimensionless term. Okay, so I'm not going to explain Buckingham Pi method here. That is a part of fluid mechanics, and it will deviate me from my topic. But I will use the result, and whenever, if you are not knowing Buckingham Pi method, so whenever you are dealing with that method, so very easily you can obtain these results. Okay, so see, so what I'm going to do, so I'm going to break this Y into two portions. Okay, one portion I will say YA. YA, we all know that is only a function of, QG, means MG will not be there. So YA over QG you can call is a function of X, L, T, K, H and EI. Okay, or you can say like this, that YA only QG is going to participate. So you can even write it like this, that YA is the function of X, T, L, KH, EI and QG, or you can say, or YA over QG is equal to a function of X, T, L, KH, EI. Similarly, my dear friends, similarly, if YA is taking care of QG only, you know what is YA? This one is YA. So it is only due to, as you can see, QG thing. So similarly, YB is going to take care of MG thing. Similarly, YB is going to take care of MG thing. So here you can see that YB is a function of X, T, L, K, H, EI, MG. KD thing I am considering now. I am applying superposition principle, my dear friend. I am applying superposition principle. So first time I am only considering KG as a load, and second time I am considering only MG as a load. So as I told you, see here that Y is only MG is to be considered. Is it clear? Is it clear, KD? Okay, good. I hope it is clear. Okay. So when I am writing YA, so QG is considered. When I am writing YB, only MG is considered. So that is why I am bifurcating them. So YB upon MG is a function of X, T, L, K, H and EI. Okay. Is it clear? Is it clear to all? So yes. Now I can say 1, 2, 3, 4, 5 and 6 is this. So yb is a function of 1, 2, 3, 4, 5, 6 term. Yb is a function of 1, 2, 3, 4, 5, 6 term. Similarly, ya is also a function of, similarly, ya is also a function of 6 term. Okay. So out of these combination, one combination is this and one combination is this. So here if you are trying to find the dimensionless term, like dimensionless term, then you will be getting 4 dimensionless terms. So what are those dimensionless terms? So 4, you can say 4 independent, 4 independent non-dimensional term can be determined. Okay, so what are those 4 independent non-dimensional terms? First one is ya अपॉन qg तो था ही, इसके साथ साथ और क्या आ गया, ei अपॉन टी क्यूब. देखो बहुत आसान ट्रिक बताऊंगा इन सबको याद रखने की. ओके, तो ये हो गया मेरे पास पहला कॉम्बिनेशन. ये मुझे कहां से मिला? सो आई ऑब्टेन दिस फ्रॉम दिस एक्सप्रेशन. ya is a function of x, t, l, k, h, e, I, g. So if I am solving them by using Buckingham Pi method and all, okay, so these are known as 4 non-dimensional terms, and these terms are also known as Rees and Matlock's non-dimensional parameters. Okay, these are also known as non-dimensional Rees and Matlock parameter. Is it clear to all, my dear friend? Is it clear to all? Okay. Similarly, my dear friend, if I am going to solve this, then I will be getting again these non-dimensional terms, ya ei अपॉन q नॉट q, क्या आएगा यहाँ पे, mg आएगा. और t का डायमेंशन ना लेंथ का होता है, तो आपको पता है मूवमेंट आ गया तो एक लेंथ का डायमेंशन कम हो गया. एंड अदर्स पैरामीटर विल बी सेम, इज इट क्लियर? टेल मी इज इट क्लियर और नॉट? मैं फिर से एक बार रिपीट कर देता हूं. देखो क्या हुआ यहां पे. दिस वी वर नोइंग that y depends upon x, distance from the top ground level, t relative stiffness factor, okay, l length of the pile, kh coefficient of subgrade reaction, ei flexural rigidity of the pile, qg lateral load. And next time in place of qg I have only considered mg, so I have written here yb, क्योंकि B वाला जो था वो मूवमेंट का ध्यान रख रहा था, और A जो था YA जो था वो सिर्फ किसके कारण था, लैटरल लोड QG के कारण था. तो मैं दोनों को ब्रेक करके स्टडी कर रहा हूं, क्योंकि देखो जब मैंने अपना एनालिसिस स्टार्ट किया वहीं पे मैंने आपको ब्रेकिंग दिखा दी. तो Y हमें निकालना है नो डाउट, है ना, बट 2 लकड़ियों के एक साथ तोड़ना मुश्किल है मेरे लिए, तो लकड़ी मैं एक एक करके तोड़ूंगा, पहले ये फिर ये. क्लियर है कि नहीं है? सर हाउ टू रिमेम्बर सीइंग फर्स्ट टाइम देम? अब बताऊंगा शशि, आई विल टेल यू हाउ यू कैन कीप इट रिमेम्बर. आई एम गोइंग टू टेल यू द एनालॉजी. ओके, सी it is dimensional term, you can even find it. I will suggest you, if you know Buckingham Pi and all, try to define these. Okay, and just study 2 to 3 times. Just watch this lecture twice. or just read these notes, whatever I'm giving to you 2 times, you will be remembering all the things. And now I'm giving you some technique. Okay, try to relate it with the structure. Okay, try to relate these things with the structure and the basic of strength of material. So it will be very helpful for you. See, I myself, I am only going to tell you how I keep them remember. I considering T as a lever arm. In my mind, I am considering T as a lever arm. You can check its dimension, it is dimensionless. It is X by Z. So X by Z is, you can say X is variable depth with respect to ground level, and when x is equal to x max, means it will be equal to length, then this is known as your total length, and it is known as z max, and it is known as your z only. Okay, so this white thing or blue thing, whatever you want to say, it is taking care of, this qg, and this red thing is taking care of this moment thing. Okay, so only one difference is there. Simply keep one thing in your mind, that mg, if I want to write mg in terms of qg, then mg is qg into t, because it's 1 degree is higher. It is movement, it is lateral load. So movement is some load into lever arm. So I am not saying mg is lateral load into lever arm, but it is some load into lever arm. So its degree would be higher. Is it clear? Its degree would be higher. Is it clear to all my dear friends? So let me explain this terminology one more time to you. So X is basically, my dear friend, X is depth below the ground level. Okay, T is relative stiffness factor. T is relative stiffness factor, and I'm going to define it later. Okay, right now I have told you it depends upon the soil, it depends upon the material. So this L is the total length of the pile. L is the total length of the pile. Now what was next? X, T, L, and this KH you all know. KH is, you can say, it is modulus of subgrade reaction. Okay, and you remember KH we have also written as KH is equal to NH into X. And what was this NH? This NH was equal to constant of subgrade reaction. Okay, so after that EI is flexural rigidity, or you can say flexural rigidity. ये स्पेलिंग देख लेना, थोड़ा सा गलत हो गई है. Flexural rigidity of pile. Okay, and QG is lateral load. Applied at pile head, and mg is moment applied at pile head. So once again I have explained all the terms. So these are the, you can say, terminology: X, L, T, KH, EI, QG, MG. So X, L, T, KH, EI, QG, MG. I have break this function into two parts. One is taking care of QG only and other constant, and another is going to take care of MG only. So it is known as YB. Okay, so Y is equal to YA plus YB. Y is equal to YA plus YB. Is it clear to you? So YA is taking care QG. YB is taking care MG. Okay, so based on this analysis YA and YB, so these two, you can say total 5 dimensionless parameters have been originated. First dimensionless parameter, second, third, fourth, and fifth. This one is fifth. The only difference here is Qg and Mg. So simply substitute Kg into T by Mg. So it is the fifth dimensionless term. Okay. Now see my dear friend. Now see my dear friend. What can we do further? Okay. It is very important to know. Okay. So I keep telling you one thing, that here the elastic deflection is small as compared to pliable dimension, and for such things, for such cases, the principle of superposition we can use easily. For such things we can use the principle of superposition. So you know that YA, what was the first term? What was the first term? YA EI upon QG T cube. YA EI upon QG T cube. I am assigning it with the AY. Similarly, I will tell you what are these things. YB EI upon Mg. See, dimension of Mg is higher than that of Qg. So Qg into T, let's assume Mg. I am not saying, please remember, I am not saying Mg is equal to Qg into T. I am not saying. But dimension wise, I can say you that the dimension of movement is one higher than that of load. So just assume Q into T as Mg. In reality, the responsible for this movement may be some axial load, maybe some inclined load. Okay. So this is By. So now my dear friends, listen to me very carefully. Here Ay is the constant, okay, which is telling you about the deflection. Here By is some constant which is also telling you about the constant. So Ay is going to tell you constant due to this lateral loading, and By is going to tell you constant due to this moment, due to this couple. Is it clear? So I am denoting this Ay and By here, and let me keep other parameters here as well. So next parameters are x by z, x by t, it is known as z, it is known as depth coefficient, L by t is known as z max, it is known as maximum depth coefficient, okay, and one more term is there, this one, kh t4 upon ei, kh t4 upon ei. So kh t4 upon ei. So it is known as soil modulus function. See, soil modulus, it is taking care of soil, it is taking care of soil and pile material, it is taking care of pile material. So it is denoted by phi x. Okay, now once again I am repeating. After seeing these dimensionless terms, I have seen here 5 independent terminology. So this one, the first term I am denoting with AY. The fifth term I am denoting with the BY. It is due to lateral load and it is due to movement. This term x by t, it is taking care of any arbitrary distance x from the ground level, and I am calling it depth factor, which is nothing but z, and L by t you can call it the maximum depth factor. Is it clear to all my dear friend? Is it clear to all? So once these 5 terminology, based on this 5 terminology, first, second, third, fourth and fifth, I will be able to analyze completely, you can say, free end condition as well as fixed end condition. Okay, free end condition as well as fixed end condition, I will be able to, you can say, analyze. Okay, so now see, now I'm starting from that point where I left yesterday. So we all know what is the differential equation involved here. So what is the differential equation here? So the differential equation was d4y upon dx4 plus khy upon ei is equal to 0. Is it clear? So it is also true for differential equation deflection due to, you can say, lateral load as well as due to moment. Is it clear to all? So it is true for each and every condition. So from here, my dear friend, you can also say, now listen to me very carefully. Yx is equal to ya plus yb. Okay, yx is equal to ya plus yb. What is ya? If I want to write ya here, it will be qg t cube upon ei into ay. It will be qg t cube upon ei into ay plus, what is yb here? Mg t square upon ei into by. Mg t square upon ei into by. So the general value of deflection at any point is depending upon, you can say, these two constants ay and by. So Rees and Matlocks have obtained this constant at various depths. You can change the depth accordingly. The value of ay and by will also get changed. Okay. Not only this. Similarly, if you want to write expression for slope, let's say sx at any distance x from the ground level, the slope is. So how can you remember the term? Like you know, it is slope and it is deflection and it is slope, and we all know the degree of deflection is one higher than that of slope. So what we can do, we can simply remove 1 degree here. So by removing 1 degree here, because rotation is dimensionless and deflection is having a dimension of meter. If you want to go from deflection to slope, then you have to decrease the degree by 1. Is it clear? So it is a into m. So now these coefficient will be taking care of slope. Okay, I am calling it slope then. Let me write here as plus mg into t, 1 degree reduce, okay. So this is slope and this is deflection. This is slope and this is deflection. Now, can somebody help me in deciding? So what should be the similar equation for moment? What should be the similar equation for moment? So similarly, if I want to write the relation for moment, we know that in moment and all, the stiffness of the material is not going to play any role. So if I want to write the general expression for bending moment at any distance x from the ground level, it will be equal to ma plus mb. It will be equal to ma plus mb, and ma is simply ma qg into t, and let's say the coefficient is a m plus mb is due to mg, b is due to mg into a, not a, sorry, b m. So this is due to bending. Similarly, if somebody wants to write it for shear, then for shear what he can do? So for shear, my dear friend, Vx at any distance, if it is equal to Va plus Vb, then Va is equal to Qg into Av plus Vb due to movement. So dimension is to be reduced by 1. Shashi, is it clear to you now how we have to write this? Qg into AV, dimension of kilonewton. Mg is having a dimension of kilonewton meter, so it is mg by T. Yes. AS is equal to 3AY के लिए इक्वल होगा क्या? मुकेश हम कह नहीं सकते ऐसे. It depends upon the condition. Here it is a case of free end, okay, and these are not that simple. Don't treat it simply as cantilever beam. Is it clear? Don't treat it as a cantilever beam. So the differential equation has been developed and they are solved analytically. So based on those solutions, we are having here the value of AY, AM and all. Okay, we cannot say it like this. Okay, so it is Vx. So it is the value of Vx. Is it clear? And similarly, one more terminology can be written. So total 5 are there now. First one, second one, third one, fourth one. So let's write one more time. Let me write this time for soil reaction. For soil reaction. So it is Px is equal to Pa plus Pb. So what is going to happen here? Reduce degree by one more time. So Pa Qg by T and Pb, it is mg by T was already there, then T square into okay. So it is the soil reaction. So it is my fifth expression. So let me rewrite all this y one more time so that you guys will be confident that how to write all this. One more time I am going to write. Okay, first expression I have written in terms of you can say y, is ya plus yb. So how I have written it? So this a portion is Qg T cube upon EI See how to read the subscript. A stands for Qg and B stands for Mg. Y stands for this. So this is deflection. So Y means lateral load coefficient for deflection. Lateral load coefficient for deflection due to movement. Lateral load coefficient for deflection due to lateral load. Okay. Second is slope. So reduce degree by one time. Third one I have written moment. Third one I have written moment. QGT AM plus mg into bm. Fourth one was shear. QG into AV. V stands for shear plus mg by T into BV, moment shear. And last one was PX QG by T into AV plus mg by T square into BP, sorry, AP. So very easy to learn. If you are knowing all these things, and tomorrow I will tell you how to get this value AY, AS, AM, AV, AP, BP, BV, BM, BS, BY. So after that analysis has been completed. After that analysis has been completed. Okay. Is it clear? So see, now tomorrow we will see, not tomorrow, sorry, on Monday we will see how to find these coefficients. These are tabulated by these and Matlock. Okay, so on what basis they have tabulated it? So I am going to tell you that, and by this the analysis portion for freehand is completed. Because what do you understand by analysis? By analysis you mean to know the deflection, to know the slope, to know the bending moment, to know the shear force, to know the subgrade reactions and all. Okay, soil reaction. So you know, if you are knowing all these things at different depth of the pile, then it means the analysis is completed, and all these values you will be able to calculate once the values of these coefficients are known to you. So I will tell you on Monday how to obtain this coefficient, and I hope these expressions are quite easy to remember. So just like slope and deflection in your strength of material on a structure, you can visualize it. Okay, like M upon EI diagram area, moment of M upon EI, so 1 degree is higher, bending moment is bending moment only, shear force value is 1 degree less than that of moment, reaction is again 1 less than that of you can say shear force. So all are running in the single pattern. So it is a complete analysis. But yes, too many crux points are to be discussed yet. So first of all, I will tell you what is AY, BY, AS, BS. For that, I am going to show you a table on Monday's class, and then I am going to give you 1 or 2 numericals so that each one of you will be comfortable on this. So one more session on laterally loaded pile. After that, from Tuesday onward, I am going to start, you can say, uh, pile group efficiency. Is it clear? Is it clear? केडी सिंह जी पहले मेन टॉपिक कर लेते हैं. मैं तो यहीं हूँ, कराता रहूंगा बाकी के टॉपिक भी, डोंट वरी. ओके, ग्रेट. Mohammed Kaif, sorry if you are not understanding. So it's my humble request, go through lecture 1 as you are saying that you are late today. So just see the lecture from the beginning. If it is not clear, then I can give you some time on Monday's class. Okay, MD Kaif, Mohammed Kaif. Okay, okay, Shashi, sure. Not in today's one. Not in today's one, my dear friend. The one which you sent me 2 days earlier, in that I told you were little wrong. Okay. Today's one is perfectly right. All the today's one I have not checked, but 2 days earlier, whatever you told, so there is some flaw in that. Okay, I am already extended the session. So your next class is at 6 of Geotechnical Engineering, and Abhishek sir is teaching you shear strength of the soil. So guys, please go through this lecture, please revise this lecture. Okay, and we will be meeting for Geotech again on Monday 4:30 to 5:30. Okay, so my dear friend, if any of my friend is interested in Unacademy Plus subscription, then just download the Unacademy Plus app, and there you can select the Gold, Gate and ESE, and you can always use this code AISH10 in order to avail 10% discount. Okay, in order to avail 10% discount, you can always use this code AISH10. Is it clear to all my dear friends? Okay. And yes, one more thing, this code is not only valid for GATE and ESE, it is also valid for various other competitive exams. In fact, all the competitive exams on which you can do preparation on Unacademy platform, like SSC JEE, CAT, IIT JEE, okay, and your bank engineering services, 11th 12th class preparation, NEET preparation. So each and everywhere you can use this code. Not you, your friend or your relative can use this code. Okay. And these are our channels, Facebook channel, and this is our official Telegram channel for civil engineers, and these are the various YouTube channels which is offered by Unacademy. So right now you are watching this channel, Unacademy GATE CE. Okay. So thanks a lot to all my dear friends. Okay, Mukesh, I'll see. Okay, and thanks a lot. Have a nice day. We will meet tomorrow for structure 10 to 11:30. After that, we will be meeting on Monday. Okay, and I will see if I can see some special lecture on Sunday. I will inform you. Okay, Mukesh, which doubt? Okay, Mukesh, I will tell you a doubt. Okay, it is not related to geotech, I guess. Okay, I will tell. Is it clear? Okay, enjoy. Don't go outside if it is not required. Have fun.